As I see people coming in, just a heads up, we're going to wait a couple minutes for people to join, but yes, it is working so far. Okay, hello. Welcome to Web 101 for actually hacking this time. We're going to be trying to build off of what we talked about on Monday in order to try and actually find some vulnerabilities. So just quick, what is web when we're referring to it? Obviously, we're talking about websites. Like I was mentioning before, today our goal is to try and break them. So as you talked about, web code is split into the two sides. You have the client side and the server side, where the client side is HTML, CSS, JavaScript, and then we'll mostly today be focusing on server side things. And the question is, why does this matter? Why did I bother to talk about this all on Monday? And that is because most web vulnerabilities will fall into two main categories. First of all, security should almost never be done on the client side. Normally, I would say never, but there have been some very niche circumstances where it had to be done on client side. So I know places like Google, for example, at least in the past, have had specific instances where a little bit is done client side, but that is way outside the scope of this talk. So just a general rule of thumb, security should not be on the client side. And the other category is when you have unexpected input, and that's the category we'll be focusing mostly on today. However, I said mostly, not entirely, so we're going to be talking very briefly about client-side security. The reason why it is not a good idea is because web browsers allow you to view and edit all of the client-side code in real time, which means, as you can see from these screenshots, if you have something where you're, say, accessing a array in JavaScript to check someone's signing credentials, there's nothing stopping someone from going into the JavaScript console and just printing out the entire array. So here you can see exactly what would happen if you made that mistake. However, like I said, we're not going to focus too much on client-side security because it shouldn't be done in the first place. It pretty much just falls down to you can do some things in JavaScript. Unexpected input is really more where it gets interesting. And that is because user input is going to be utilized in some way. You're not going to ask the user for information if you don't plan on using it. So it could be stored in a database, could be displayed on the screen, whatever you're doing. And in order to do that safely, you need to take special mitigations. Or else you have things like, for example, cross-site scripting, or XSS for short. XSS is an example of code injection into HTML, which allows you to run JavaScript on someone else's computer. So you can see, like if you have, it's very easy to imagine a website where it asks the user for their name, and then it prints out a message just greeting them. But what if that person's name has valid HTML in it? Well, there's nothing on the browser end to really distinguish what was user input and what isn't. So it'll print it as if it's HTML that you put in there. So if you have, for example, a script tag, like we were talking about how you can use those in order to embed JavaScript in the middle of HTML, the person's name could have JavaScript that will just get run on anyone who looks at it. So here you can see this screenshot is actually from the old Google Chrome XSS auditor. It is no longer used because it had various issues and people didn't like it, so they ended up discontinuing it. However, you can see here that they have a script tag that was actually in a get parameter and ended up on its way into the page. This is the idea of what cross-site scripting is. And one of the most famous instances is when somebody found an XSS attack on Twitter. You can see here, they posted this really long tweet. They had an extra 2 characters, they added a little heart there. And what this tweet does is anybody who looks at it, this tweet will automatically retweet itself from their account. And now it's not very important to understand specifically what the JavaScript is doing, but essentially what it's doing is it's going through and it's simulating all of the things that you would be doing to click on in order to retweet. So it's using JavaScript to find that retweet button and then automatically click it through code. And then it also has a little pop-up on your screen so that you realize exactly what happened. And as you can see, this ended up getting 83,502 people just because at the time there was nothing you could do to stop it. If you looked at the tweet with JavaScript enabled, which almost everyone has, it would just happen. Another type of one of these code injection attacks is a SQL injection. SQL is structured query language, and it's just used to communicate back and forth with the database. So you can do things like produce search results, you can do things like looking to see if a username and password combination are in a database, whatever you're doing. However, the issue is that if you decide to do it incorrectly, it's possible for the user input to be run as code. So in this example here, we have select star from table where field equals the user's input. So what that's saying is it'll select everything in the table wherever the case is true that whatever field you put there is equal to whatever the user said. And the user input is put within quotes to treat it as a string. The only issue with that is what happens if the user's input also has a quote. If you're not careful, it'll actually close the quotes, and then the user's input will be run as code because it's no longer in a string. And this is something that happens everywhere, no matter how safe you think you are. In this case, this is actually a screenshot from a paste bin where there was a massive leak because someone found a SQL injection attack on MySQL, the people who make one of the most popular SQL distributions in the world. So literally no one is safe. And a little bit closer to home, here's one that one of the RPISec members actually found and reported recently in RPI's academic Discord bot, where one of those was in there as well. Like I said, this happens all the time, regardless of how much you understand security. It's just an easy mistake to make. Another very popular one is file uploads. When you're having the users upload a file, like say for example a profile picture, how do you make sure the file is safe? Do you check the file extension? Do you check the MIME type? There are many things you can do, but also all of those can be spoofed in one way or another. Like you may want an image to be uploaded, but what if it's PHP? Or what if it is also an image and PHP at the same time? Like what happens if you have a profile picture that's named picture.php%00.jpg? %00 is the URL encoding for null byte, which means, as you can see in the screenshot, if you upload that and it's not handled properly, then when it gets stored locally on the server, the null byte will actually terminate the file name string before the image file extension, which means it'll be left as a PHP file waiting to be run. And there are many, many examples of things like this. Another example is like PHP has many different file extensions, so if someone's trying to use a blacklist-based system to disallow any of those file extensions, it's very easy to forget one. So there are many different instances of file upload going wrong. And like web vulnerabilities are surprisingly simple. We covered a couple examples. There are other more in-depth various ways of utilizing these, but they really do only fall into those two categories of either something's being done on the client side that shouldn't be, or that code can be put somewhere where it wasn't expected and it'll actually get run. And obviously you have varying levels of payload complexity, but the same ideas apply. And I fully understand this is a little bit difficult to understand just conceptually, so we're going to go through quite a few examples using what is known as the Damn Vulnerable Web app, which here is a link to on the slides. And feel free to download this. I have an instance running locally on my laptop right now. And what we will do is we're going to play around with that a little bit. So when you do it and you get it set up, this is the screen that it shows you, and you can see all of the different types of attacks that are over here. We're not going to go over brute force because that's fairly self-explanatory. It's just someone's using a bad password and it's very easy to guess. But let's look at command injection. So you see this is prompting us for an IP address. If I put in, say, localhost, takes a couple seconds, but then it gets back to us with the actual results. And that seems fairly useful. And let's look at the source code. Like I said, you typically won't have server source code if you're playing, say, a CTF, for example. But in this case, it gives us source. To make it easy to read, I pulled all of the source over into VS Code. So we can see what this is doing. And it's just taking the IP address that the user gives, and then it's just doing a shell execution of pinging and then that address. In PHP, the period is a string concatenation operator, so it just takes what we have and shoves it in there. So in the previous example, what was happening was we would be running ping-c4, and then it did localhost. But what happens if at the end we say put on a semicolon? For those of you who don't know, in Bash, you can have a semicolon to separate multiple commands in one line. So if I do a semicolon and ls, well, what happens? Well, we can try that by just taking that little user input string that we made, pasting it in and see what happens. So once again, takes a couple seconds to do the pings, and if you look, that looks like ls. Just make it a little easier to read. I'm also going to throw in an echo. But if you look, it's right there. We have arbitrary command execution on the server from this. If we wanted to, we could do something like, say, cat etc password. So as you can see, we can read arbitrary files. So moving on from command injection, we also have what's called cross-site request forgery. This, you can think of it almost as, in many cases, it ends up being kind of a glorified XSS, but with the goal of making somebody else submit a form without realizing that they did it. Typically done through, say, a link. Or it could be done if you have XSS vulnerability. Instead of putting in JavaScript, you could put in a form and a JavaScript to have that be submitted. There are many ways to have it happen. But as you can see, it asks for change of password. If I just do one thing and I do something else that doesn't match, it says they don't match. If I put two things that do match, it says it changed. So it's just checking to see, are these two equal? So let's look at the source code to see how this is happening. So we have, first it checks to see, is there a get parameter called change? That's simple enough. And then we also have, it just takes the password new parameter and the password conf parameter, checks if they're equal, and then if they are, it'll go through and actually change the password. Otherwise, if they weren't equal, it says they didn't match. So fairly simple. One of the really easy things about get parameters, and this is not remotely a security thing, however, they can be done just from the URL. So you don't even need to use a special tool. You can just do it from in here. So we said we needed to have a change parameter set. So what we can do is say if we go to CSRF and we do change equals whatever we want, doesn't matter. And we also have password new needs to be the new password. So new password equals, I don't know, pass. And we need password conf equals pass. So this is a link that could be sent to somebody, and you can see that when they actually click on this link and go there, their password instantly gets changed. Just to demonstrate that, I put in something that didn't work so you can see it actually change. You can see the passwords did not match. We go back to that link we created before. If we click on it, it would immediately change the password of the user's current account. Next, we have a file inclusion vulnerability. Unfortunately, I'm not going to be able to do anything that goes to external URLs because of the fact that the virtual machine that I'm running this in, or Docker container specifically, does not have access to the network. However, this is just where we have, it lets you go through, there are some files in here, it lets you open them internally, like a little box. So let's see what this is doing behind the scenes. So you can see it's quite literally just saying what did the user say the page they wanted to look at is, and then it's going to use that file variable later to load it. As you can see, when I click these, the page is changing in the top. But what happens if I don't ask for something in here? Like what happens if I ask for, say, etc password? Well, you can see there was no code actually stopping me from doing this, so it loaded that file in and displayed it on the screen. So at this point, we can read arbitrary files. If you were connected to the network, you could actually be loading arbitrary files from other places on the internet. So you can take this local file inclusion and you can escalate it to be full-on remote code execution. But regardless, there's not really too much to talk about with file inclusion. Obviously, this is just they didn't check for it. So let's look at file upload. This is something where it just asks you to upload a file and it uploads it. So let's say if I just go and I look for some sort of image, right? That's good enough. If I just say, maybe not. Alright, so I can just take this image. Doesn't really matter, I'll just save it to my desktop. So I have an image now. And it will let me upload this image, upload. Says it was not uploaded. Let's see what's going on in the back end. So you can see it's going through, it finds this. It had an issue actually loading it, which is why I gave us that error. However, one thing that's worth noting is that at no point in any of this code does it actually mention any file extensions. It doesn't mention anything about the file type, actually. What that means is that we can upload whatever file we would like to. So, for example, I happen to have this backdoor.php script on my desktop. This is something that's freely available on GitHub. There's a simple one-line backdoor repo, just has one file in it, and it's this file. I got lazy of actually going through and Googling it every time, so instead, I just saved it to my desktop. But I could upload it, and you can see it let me upload it without any issues because it didn't bother checking. Which means, if I say, it told me where I uploaded to, so I can take it, and if I try to go to that, looks like nothing happened. However, if I actually use it correctly, like for example, it wants a get parameter called cmd of what to run. So if I tell it to run ls, it will run ls. And I have full control over the server once again. If you would like to see what this is actually doing in the background, this is fairly simple. It's just a matter of checking, is there a cmd parameter? If so, it's going to take it, and then it'll call system with it, which is just run it on the system, and that's all it does. Fairly simple, but obviously very powerful. Once again, cmd read etc password. Oops, I forgot to actually cat it, and there you go. Just like that, they didn't bother checking the file upload properly, which means we have no issues getting remote code execution. We're going to skip over CAPTCHA stuff just because it's not really anything that special. But SQL injection, this is an interesting one. So if I say user ID of say user, nothing's there. I believe, is there one called admin? I don't even know. But regardless, we can see nothing's really coming up. Let's see what's happening in the back end for this. So it's getting the ID that we are sending it. And then what it's doing is select first name, last name from users, where user ID equals, and then the ID that we put. Worth noting, there was 0 checks on anything regarding how the ID is formed. There's nothing to prevent us from putting, say, a single quote, which is where things can go really wrong. So if we look a little bit closer at just this query. So we have select first name, last name from users where ID equals ID, right? So everything between these quotes is user input. And just to make it a bit easier to see what's our input, I'm going to add some tabs in there. They're not actually part of the input. But what if our, see, as you can see, if we start with a single quote, that closed that single quote. which means we're no longer in a string, we're in actual SQL code. So what we could do, we can say where user ID equals that. If we want to get everyone, we can say, for example, or an empty string equals a quote, because this quote closes that one. And once again, remember that these tabs don't actually exist. So we get rid of them. This is what actually gets run on the side of the server. It will say select it from users where the user ID is blank, or where an empty string equals an empty string. This is always true, which means that or user ID equals an empty string is also going to be always true, which means it'll get everything in users, specifically the first and last name columns. So if we look and we take that input we were talking about, and if we put that as the user ID, you can see we get everything. And it's worth noting you can do a lot more things than just make sure that everything gets passed to you. You could say, for example, add things to the table. You can remove things from the table. You can get random other things from even other tables. You could delete the entire table, so just remove all the data they had stored. SQL injections are pretty bad usually. SQL injection blind is the exact same thing. However, it just doesn't show you any output. So we're going to skip over that one because it's effectively the same thing. And then we get into the various types of cross-site scripting. So this is one where you can just choose a language from a drop-down. You have a few options, not too much, nothing really interesting looking. So let's see what's happening in the background. Well, this one outright says there's no protections. So what could potentially be happening? If you notice, as we change these languages, there's a get parameter that's being changed to go with it. And that's being done because if you go there, it'll set that as the code. So I could put something totally random in there, see what happens, and see that gets loaded right here, which could be used for various different ways. So what we could do is say, for example, what if I want my language to be script, and we'll just use alert. Well, if that's my language, that actually gets run as JavaScript. As you can see, we got an alert. And this JavaScript can be done to do many different things. For example, you can use that in combination with some sort of requesting feature, whether it's just using fetch or whatever you want to use. You can use that combined with like a paste bin or a request bin, something like that, in order to catch traffic and then use that to actually exfiltrate data from the person. So you can use this to, say, steal cookies, or if someone has something that only they can see because they have to be signed in, well, this code is getting run from their account, so that would work. You can actually see things from the other user's account. There are a whole bunch of different things that could be done. Here's another type of XSS where, see if I just say my name, it says hello. This seems familiar, right? I talked about this exact example actually. And if we look at what's happening, what it's just doing is if there is a name, then just print their name. Once again, there's no check to see is their name valid HTML. So if we want, what if I want my name to be bold with the B tag? As you can see, my name's bold now. They're not doing anything to stop this. So what if my name happens to be script alert? Well, once again, it will get run because there's nothing to stop us from putting in HTML tags. And even if they do, there are other ways. If they try to get rid of the word script, there are other ways to do it as well. There's also stored, and this will be very familiar if from the Twitter example. So if I say my name, and then I have a message, I gotta sign it so you can see that. So once again, let's see what's happening here. So we have it gets the message, it gets the name. So you can see it's actually removing all slashes, and it's doing quite a few things to try and it's called sanitizing the message input. So in theory, it's not going to work if we tried to do it in here, but let's see, did they do it well? If I do script, I'll just throw a message in there. They obviously didn't do a very good job because it works. Also worth noting, this is a call to stored cross-site scripting because this is staying there, which means if we refresh the page, it'll happen again. And actually a second time because it actually resent my message. Let's check, does it work inside the name field as well? Well, it's kind of hard because we don't have very many characters. But we can even leave the page, go back, and this will still be there. That's why it's called stored. CSP, unfortunately, I can't really show it because it involves loading JavaScript from other sites. This is a very interesting topic. I personally enjoy it. There was a challenge on it actually at Seesaw qualifiers last year that if you're interested in how CSP works, I'd recommend looking up some write-ups for that. However, like I said, we're going to have to skip it just because we don't have access to the network. And this last one is just JavaScript, which means it's doing things locally. So it says submit the word success to win. So if I say just copy success, paste it in there, invalid token. And I don't really know of any tokens. So let's see what's going on here. If we go and inspect element, right, we can just look at the form, and oh, right here, there is this hidden token field that has a value in there. Presumably, this token is actually meant to match the phrase, which is change me. Just to make this easier, I'm going to make that visible so you can see that actually is right there. And if we look, there's this JavaScript has this whole ugly function. I have no idea what this function is doing, nor do I particularly care, because it doesn't matter. What we're interested in, you can see right here, there's generate token. So okay, how is a token generated for a phrase? Well, it will just run MD5 on a lot 13, which is defined right here. Which means there are actually two ways to do it. In theory, if I do that, I can just call generate token. I just call generate token, and this works because in the function, it doesn't take an input. It actually is getting the element from right here. So if we just change that and then say call the function again, it changed the token. And if we submit that, you can see it actually matches. And as you can see, that is all of the categories that the Damn Vulnerable Web app actually covers. However, if you are interested in any of these topics, I highly recommend checking it out because they actually have many different levels of security. You can go anywhere from low to impossible. And I'll show you quickly. You can look at all the levels at once. This is a bad example with the JavaScript. However, if we look at, say, file upload, and if we want to look at all of the levels of file upload, this is what's going on in impossible. Here's high, here's medium. Obviously, each one gets harder. So if you're interested in any of these topics, I would highly recommend setting up either a virtual machine or a Docker container, running this locally, so that way you can just try out the higher levels. Obviously, low isn't very difficult, but trying this out will definitely help you, obviously playing CTFs. And as you play, you'll eventually just pick up on some topics or little hints that you may not have noticed. For example, many CTF challenges will mention something about an admin. If a web challenge is talking about an admin, it's probably going to be either XSS or CSRF, because those are the ones that involve getting someone to look at something. But once again, those are just things that you pick up as you play. And really, that's about all we have for today. If you have any questions, feel free to post them in the chat or to come to our Slack and ask questions. You can ping me there. My handle is Radnor, Radnor. But other than that, hope you all enjoyed the talk.